Good morning. Today we'll be dealing with comparing central tendency, that is our mean, median, and mode, and variability in terms of standard deviation, variance, range, and interquartile range for a different data set. In terms of mathematical practice, we'll be reasoning in terms of abstract and quantitative reasoning in here, and dealing with critical thinking skills. Let us first have a review regarding central tendency and variability. So for central tendency, there are three different measures for such as our mean, or what we call the average. We also have our median, which is the middle term, and we also have the mode, or what we call the most frequent term. In some cases, the mean, median, and mode are the same, in which case that will say that our probability or distribution of the data set is in fact what we call a normal kind of data distribution. Let us now proceed with what we call our variability. So there are different measures of variability as such. We can talk about variability in terms of range, which is simply the difference between the maximum and the minimum points. Those are the highest and lowest points, respectively. We also have what we call an IQR, or what we call an interquartile range, which is in this case will be the length of the first quartile and the third quartile. What we mean is the upper quartile minus the lower quartile. And once again, the range in case of a box plot like such, then the range will be the maximum minus the minimum points, minimum point or value, and that will be our range. Also, not only that, we have our standard deviation as well. Usually in a TI-84 calculator, we can see it as such, what we call a sigma, a letter sigma in there. And we also have what we call a variance, which is basically the square of the standard deviation. So our lesson will focus more on comparing central tendency and variability in different data sets, but we will also be showing you how to compute for this using a TI-84 calculator or our Desmos. Let us now consider our first problem in here. An athletic director asked four groups of students, what is the most that you would pay for an athletic event? The responses are shown below. So we have a table here, amount students would pay for athletic event. We have four groups of five values each. Which group or responses each? Which group's answers showed the least variability? So let's use our Desmos first, and how to get variability in this case. So in terms of variability, we can either look for the standard deviation or the variance in this. Again, that will be a standard deviation, or it can also be a variance. And again, we can use either TI-84 calculator for this, or we can also use our Desmos. So let's use our Desmos for here for now. I am now using Desmos for this case. So on the first in there, I would put any name for group one. Maybe I would say G1 in that case. So for that G1, then I would put um, an array of values as given in here. So G1, I'll put the following 5, $4, comma, that's 3, 3, and 2. So that will be my G1 having 5 elements. Now I'll do the same for all the groups. So in this case, I'll put G2, and then in G2, I'll do the same. So take your time to put all of those for all of our 4 groups in here. So we have put all of the values in here now for G1, G2, G3, and G4, corresponding to the 4 groups in this case. Now, since we are looking for their measure of variability, again in here, we can either use our standard deviation or variance. So what I'm going to do using our Desmos is to click on our keypad button. Let's go to our functions, and under stats, let's look for what we call STDev, the standard deviation, or VAR, or what we call a variance. So let's talk about standard deviation in here first. Standard deviation, and I would put standard deviation for the G1 for now, and see that it's 1.14. I'm gonna do the same for the rest of the groups. So I'll put in here again STDev, so we can actually type it in as well as like that, and I'll put stdev of the next G2. In that case, that's 1.3038, and I'll do the same for the rest. For number 7, I'll put again, I can use once more functions under stats stdev, in this case of G3, which is 1.3038 again. And the last one for for the next one, again, I can simply type it as stdev or stdev parenthesis G4 in this case. And I got a 0.5477. Now going back to the question, which group's answers shows the least variability? So again, we have the standard deviation for G1 or group 1 to be 1.14, for group 2 to be 1.3, for group 3 to be 1.3 as well, and for group 4 to be zero point 0.5, which means that in here, the group that has the least variability will be group number 4. As we can see in here, for group number 4, we can see the values are near each other, meaning there's not much spread or dispersion of values compared to 1, 2, and 3, or relative to the other groups. So once again, we have actually seen in here that group 4 actually has the least kind of variability. And as we noticed, those values that are near each other or close to each other have the least variability. My question for you guys will be, which of these groups now will be having the highest variability? Let us now go to our second question. The table shows the number of turkey and ham sandwiches sold by Derby's Deli for several days in a week. So we have our table in here about sandwiches sold at Derby's Deli. On the second column, we have the turkey sandwiches sold per day. And on the third column, we have the ham sandwiches sold per day. What is the difference between the median number of turkey sandwiches sold and the median number of ham sandwiches sold? So again, in here, we can compute for the median value of each of those turkey and ham using, again, either our Desmos or our TI-84 calculator. This time, let us use our TI-84 calculator for this case. So on our TI-84 calculator, we make sure that the random access memory is cleared by pressing second plus 7, 1, and 2. So again, make sure that it is cleared. After that, we're going to go to our stat and number 1 for edit, or we can simply press enter. Under L1, we can put all of the values for the turkey sandwiches. So under L1, we're going to put the following: 7, enter, 13, enter, 8, enter, 15, enter, 12, enter. So don't forget to press enter up to the last value in there. After this, we can press right so that we can go to L2 and plug in all the values for the ham sandwiches sold. So under L2, I'll put the following: 9, enter, 11, enter, 8, enter, 6, and enter, 16, enter. So we now have put in the values for the ham and or the turkey and the ham sandwiches respectively. Now in this case, there are a lot of different ways on how to get the median, but I would say one of my personal things to do, consider, is to graph the box plot for this case. So after this, what I'm going to do is to press stat plot. That will be second y equals. Under plot 1, I'll press enter, turn it on by pressing enter. Under the type, I'll click on the box plot for it, which is the fifth figure, pressing enter in there, and I'm done with that. Now after that, I'm gonna create another plot. I'll go above on plot 1. So I'll go now to plot 2. Now again, sorry, to go to the second plot, I'm gonna create another stat plot. That'll be second y equals once again. And this time I'm gonna go to plot 2. So that's for the second plot. And I click on the following in here, press enter. I'll turn it on. Under the type, I'll click on another box plot in here. Under XList, since my plot 1 is about L1, then my XList in here should be L2. So if I can see, L2 in here is in fact that blue above number 2. So to get that L2, I'll click the blue one, which is second, and then number 2 to make it L2. And I choose a color red, but I can choose a different color as well if I want to. After this, what I'm gonna do is to click on zoom, and I click on zoom stat, which is number 9. So in here, I have seen the blue one and the red one, which is again, the blue one is my L1 on the turkey, and the red one is my ham in this case. Let us now get the median for this. So to get the median, I'll press trace. So under plot 1, the median is 12. That is for the turkey. And if I go down, the median for the ham is number 9. So again, the median for ham is number 9. And the median for turkey is number 12. So let's go back to our problem now. For the turkey, we got the median to be 12. That one is in blue. And for that one in red, the ham is in fact median equivalent to 9. Going back to our case, with our box plot in here for our TI-84 calculator, the blue one is for the turkey and we got 12. If we go down, then that'll be 9 for the ham. After this, we're going to get the difference, then that'll be a median turkey minus median ham, which will turn out to be 12 minus 9, equivalent to 3 in this case. So again, for number 2, The difference between the median of turkey and the median of ham will be 12 minus 9, which is in fact 3 in this case. Our next question in here, our additional question in here would be, what do you think will be the difference between the interquartile range for the turkey as compared the interquartile range of the ham? We are now on the third question. Four teachers have a test or gave a test to their classes. A summary of the test results is shown below. So we have Miss Lee, Mr. Green, Miss Smith, and Mr. Wong. Which teacher's class has the widest spread in the middle 50% of the test scores? So again, we're talking about widest spread on the middle 50% of the test scores. So as we may see on the data, all of them have minimum, Q1, median, and maximum. So you can consider this, in fact, as our box plot, where the minimum the minimum is the leftmost whisker, the maximum is the rightmost whisker, lower quartile is Q1, upper quartile is Q3, and the median, or what we call the second quartile, is at the middle in here. So when you talk about the middle 50%, the spread of the middle 50% of the test scores, we are in fact talking about what we call IQR, or the interquartile range. Again, the interquartile range will simply be the difference between the upper quartile, that's Q3, and the lower quartile, which is Q1. So with that being said, we're simply going to compute for Q3 minus Q1 on each of the teachers' box plot scores. So for Miss Lee, we can tell that that will be 89 minus 73, which is equivalent to 16, and we'll consider the rest, the same computation for the rest of the teachers. So we have seen the following values for the interquartile range of each of our teachers here. For Miss Lee, we got a 16, it's 89 minus 73. For Mr. Green, that's 89 minus 75, 14. For Mrs. Smith, that will be 93 minus 78, 15. And for Mr. Wong, that will be 96 minus 83, 13. So again, which one has the widest spread, then that means that will be the one that has the highest IQR, or interquartile range. So with that being said, then we can say that that will be Miss Lee in this case, having the highest interquartile range. Again, an interquartile range is another measure of variability or variance. In fact, it is 50%, middle 50% of the test scores, because in our box plot, this is also called a quartiles. That means it's 25% each segment in that case, meaning 25% of the whole population or the whole scores are in each of those segments. But when you talk about the interquartile range, that is considering the middle 50% of the whole population, or in this case, of the whole scores, will be in there. And in this case, that will be highest IQR obtained by the class of Mrs. Lee. Another additional question for this case, what do you think, or who do you think will be the teacher who will have the highest range for this particular problem? So as for your own work, kindly do this one in here. The number of books sold by each student in two classes for a fundraiser is summarized by these box plots for class 1 and class 2 regarding the number of books sold. The principal concluded that there was more variability in the number of books sold by class 1 than class 2. Which do you think is true about the principal's conclusion? So again, this is talking about variability. So we can talk about Well, as a note, when you talk about variability, then we talk about either standard deviation, range, interquartile range, or variance. But we're not talking about the central tendency, like mean, median, or mode for this case. So once again, for this topic, we have focused more on comparing either central tendency or variability or both for different data set. We have done TI-84 computations and also Desmos computations, but you are free to use any calculator or calculating online device that you have in there. But certainly our focus is more on comparing the measures of central tendency or the variability. Once again, let me know if you have questions regarding this particular topic. And once again, tell me quando you when do math.